All right, very good. I will take over. So this is Catherine Plaisant. And so I assume we are sharing, you could see my screen.
Yes, we can see it.
And so this is a more informal break because, you may want to have lunch, you may want to stand up and stretch and move and turn off and come back later. But we will show some video, which will allow me to eat lunch too. So that's hopefully convenient for everybody. And we'll make sure to be done at 1 or just before 1 so that you have time to link to the different URL Zoom links for the afternoon parallel session. But so the plan today is to eat lunch, indeed, watch videos together. And I just wanted to say that you could also, if you really need a break, watch those videos later. You won't have the commentary that Ben and I will add to the videos, but you could find the link to the slides on the symposium program with the embedded videos, so you could run the videos. So, one reason to do this today is also to celebrate the fact that the completion of the historical archive video project that I did for the past 2 years, really trying to save a lot of historical videos that were saved only existed in videotapes format, VHS videotapes. And so we want to show you some of them. And of course, we picked the one from the HCIL. And I chose the earliest videos that we have. And we'll cover topics like hypertext. Actually, this one is not a Kai video, but it felt like it was so important. We'll show it to you. Then the videos from the 91, etc. So the 90s in general. I picked videos that fit those early themes, but also, videos that I made because I'm retiring and this is a way to celebrate, but there are many more. And again, I'll show those links at the end, but they are in the slides that you could find on the website. So the first one we're going to look is actually a preview of that historical Kai video project, because you might be interested in the history of the field and find some of those old videos interesting. So so we have, just in summary, 20 years of videos and more than 300 videos. So let's see, I have to start these videos, make it big. I will turn on the subtitle because we do not have captioning for this. Starting in 1983, Kai had a technical video program. Authors recorded videos of their work, mailed videotapes for review, and the program was published as a VHS tape. The tapes were shown at the conference, broadcasted in the hotel rooms, and sold afterward by ACM, initially as issues of the SIGGRAPH Video Review. While all Kai papers were digitized a long time ago, the videos were not. So we did that and tracked down the authors who gave permission to add the videos to the ACM digital library. When they will be posted by ACM, you will be able to see things like Doug Engelbart, the inventor of the mouse, demoing his invention, but also evidence that users had not learned to use them yet.
You'll see early examples of virtual reality, tablets, smartwatches, 3D modeling, and more. It's really interesting to see just how early these technologies were already being conceptualized. Some of those videos played a role in legal cases, such as the slide to open controversy. This is an amazing resource with over 300 videos spanning 20 years. The collection features work from companies such as IBM, Bellcore, Xerox, and many more. Here's a small sample of some more interesting videos from the set.
Move that. Where?
where it was.
The graph constantly changes to keep the area near the focus enlarged. Smooth, real-time animation provided the feedback necessary to keep the viewer oriented.
What can you do? Watch the videos and their influential designs. Record videos of your prototypes for future generations of researchers, journalists, and historians, because videos are the best way to describe interaction. Submit those videos as supplementary materials to your papers, because who knows if your website will be available in 40 years? And finally, write about the history of your field and cite those videos. Thank you. All right, so that's a good question. How do you get out of this video? There we go. So I'm back to, so this is not the video, it's really me in live. And just to add a few comments on this video, this preview, this project. So the video mentioned that they would be on the HCM digital library, but it's now also on the HCIL YouTube channel. And all the videos are available. So I encourage you to take a look. And but let's move on to the next video. So I'm having problem switching here. What's going on? Oh, I went to the actual. I made those slides live, which made it easy to click on the link by mistake. So I'm going back to my slides I wanted to do. No, this is not it. Oh, this is embarrassing. So let's go back to presenting this. All right. So now I go to the next one. Yes, so let's skip this. So now we go to the actual samples of the HCIL videos that I selected from the Kai videos. And I mean, those videos were really prepared for HCIL. Actually, you should know they were all prepared for the symposium. We would always prepare those videos to show you at first. And of course, at that time, we would generate, we would print, when it's not printed, we would prepare those VHS tapes and hand them out to everybody that was coming to the symposium in person. And we would also make them available. People would write us letters, not email, letters. It comes to the mail saying, I want a copy of the video. So it just shows how things have changed. So let's move on to the first video I want to show you is about our very early work on hypertext and hypertize, and in particular, the introduction of the embedded links, something that seems so familiar to you. But the video is really from 1998, where the state of Maryland, a video channel had interviewed Ben Shneiderman, and he demonstrates those links on an actual demo, which sadly we can't do anymore, because nothing works. Those old computers and old demos have a very hard time, which makes the video really crucial to keep the history of our field. So let's go to the, and of course the effect is those links that you see now everywhere on the web. So let's jump to the video, and apologies for...
Ben Shneiderman heads the lab. One of the early projects, starting about 1983, was to develop an electronic encyclopedia. In those days of the green screens and of typed commands, everybody's thought about the way you would travel through an encyclopedia was to see some numbered items which you would type the number of that menu. And so I asked Dan Ostroff, who was the student program at the time, if we could highlight the words in the text and allow users to click on them with a mouse. A year later, we produced the world's first electronic book. This was the title page online. You could look at examples like a travel guide. This one was to San Diego. And you could look at features of for example, the San Diego Zoo. So this rapid way of exploring was an important step forward that Tim Berners-Lee had incorporated in his proposal for the World Wide Web, and he called these hot links. And here we are 15 years later, and the work of the Human-Computer Interaction Lab is available online with highlighted links, including some of our early projects, such as the Visible Human.
Here we go. So I
Yeah,
almost didn't
if I
get another slides.
jump
Maybe
in.
Ben want to add a few comments there.
Yeah, just thank you. Catherine's heroic effort to capture the history of the HCI field is really bore wonderful fruit, and all those 300 plus videos are available. And this little sample, which is HCIL related, takes me back to the early days and the days of hypertext. And that was a really wonderful demonstration. It shows how far we've come from the rather crude looking low resolution screens to the higher resolution and more rapid performance that we expect with very high quality graphics everywhere. So it's just, you know, a pleasure to see all these changes, and thanks for doing it. I hope students appreciate the trajectory of how life has changed that much, and that it's a resource here for journalists and for researchers and historians. And there's a growing circle of historians at museums and journalists who are writing more about the history of HCI. There's a growing awareness about what the huge impact was of research in HCI, and especially and HCIL's contribution to that, and that it's this, you know, moderate-sized community that worked on HCI that transformed the world in wonderful ways. So thanks for showing the hypertext. It was sort of a great example of how a small idea had a huge impact. And there are alternatives. Early versions of the web had other kind of ways of following links, but it was a crude, difficult, and unpleasant way. But the clicking on the words, then highlighted words embedded in sentences, turned out to be very powerful. Yeah. Thank you. So we'll go on to some of the other examples, and I'll let him carry it, and I'll get ready for my 1 o'clock tutorial on human-centered AI. Thank you.
Yes. I just wanted to add something. That seeing those two videos side by side about, you know, the previous one showing the invention of the mouse in 1968, and even in 1983, I don't know if you noticed, or even in the demos that was done later, we were still using arrow keys to navigate through the links, because the mouse existed, but practically almost nobody was using it yet. It was not commercially available. It took a very long time. And we needed to use those interfaces that looked very familiar only with a keyboard, using the arrow key. So there was a whole set of algorithms to find a better way.
So the green screen and
right.
Yeah, the green screen displays, the green screens, which were the widespread use ones, only had simple ways of highlighting. You could be boldface, you could be italic, you could be underscore, and you could inverse. So we had only 4 options. Moving arrow keys was the common way. Yes, for mouse on newer systems already, we were PCs and beginning to appear, and the Xerox Star Wars began to make more common, but yet the arrow dominant. So we designed for arrow key, tested for those, and also eventually for the mouse, and touch screens became our later. We built kiosks, museums, and other situations. Thank you.
Ben Shneiderman.
I don't want to start. Okay, here we go.
Touch screens.
Another example of, actually it was a small idea, but somehow it made a lot of noise. So the general context was we were doing a lot of very early touchscreen interface work, where at the time, touchscreens were described as a way to manipulate an interface, but you could only create buttons that were as large as your, or larger than your finger, because obviously you couldn't touch something smaller than your finger. And then we were able to show that it was possible to do high precision touchscreen, mostly by you touch a screen, get a cursor above your finger and adjust the position so you could really select what you want and lift off. And we did very early keyboards and all kind of examples of what you could do with touchscreen. And of course, now that we have, especially the mobile devices where we use touchscreens all the time, a lot of those ideas are, everywhere. So from the keyboard to, and so the videos I picked for next is somehow my most famous video, even though we never even wrote a paper about this idea, it was such a small thing, but it was about doing touchscreen toggles, and it became central to the war of Samsung and Apple for the slide to unlock patent. So let's look at that video.
I can't resist adding the words about this high precision touchscreen, which was in 1988 in the CHI conference in 88, where we showed these hype ideas. One of the reviewers for the journal did not believe that we could do it. And that's why we made the video, to show that it really was possible. And the idea of sliding your finger became in Apple devices. Steve Jobs visited our lab in October of 1980. Of a relationship, and enabled us to see how these ideas would. Thank you. Onward to slide to open.
All right, slide to open. Make it big. It's funny, it didn't make it big. Weird. What am I doing? I'm doing something wrong, obviously, that didn't happen before. All right, here we go. Large. You can see those are really the CHI videos with all the introduction from SCM. Oh, what happened to the sound? Did I stop it? Whoa, no, maybe there is no sound yet. Here we go.
Hello, I am Catherine Plaisant from the Human-Computer Interaction Laboratory of the University of Maryland. I will be discussing the design of touchscreen toggle switches for novice users. Toggle switches are those buttons, levers, sliders that allow us to directly turn on and off lights, radios, TVs, and any other type of devices. Computers now allow the design of new type of toggle switches. However, there are still many inadequate designs that can be found in existing systems. For example, here, it is quasi impossible to say what the status of the toggle is. On, off, nobody is really sure. Here, the box is a good clue. But this shows a classic problem. I don't really know if the box around the on indicates that the device is on, or if the box indicates where to touch to turn the device on. Another problem is that the toggle has to be identifiable as a toggle. Is this just a label, or is it a toggle? If I touch quit, I'll probably quit. So if I touch on, the device might turn on. Or is it already on? Those are the type of problems encountered by novice or first-time users, and we wish to address those problems in our designs. We implemented 6 types of toggles, ran a usability test, and refined some of the toggles according to the result of the test. Our practical goal was to select a usability-tested, error-free toggle to be used in a home automation system. This work was conducted with Custom Command Systems, a small Maryland company who design and install home automation system which integrate entertainment, security, lighting, climate control, etc. in affluent homes and offices. In the house, the homeowner sees the screen flush mounted in the wall or in the cabinetry. They locate the device in a menu structure and then manipulate the toggle. For example, here you see the one-button toggles. In this second toggle, both possible states are shown and only color is used to indicate the status of the device. This is a 2-button version. A simple 2-state animation shows a status change. This is a more busy graphic design, but the mechanism is pretty easily recognized. In the very similar rocker version, the motion fits well with the finger's gesture. With the slider toggle, the slider has to move from one side to the other. Same principle for the lever toggle. Having to use a sliding gesture makes the toggle slightly more difficult to use, but greatly reduce the chances of advertently switch the toggle. We ran a usability study with 15 subjects. They were given representative tasks, and error rate and user satisfaction data were collected. The results showed that no error were made while reading the state of the toggle. A fairly consistent ordering was found. For example, here the subjective preference index shows the ordering 1 button, rocker, 2 button, words, slider, and lever. The 1 button and rocker were significantly preferred over the slider and lever. Nevertheless, we observed some important individual differences. We think that the 1 button was preferred because the graphic design is relatively simple and the state is easily read. But the problem remains that push buttons are not always recognized as toggles. The usability test also highlighted some problem with the implementation of the toggles. For example, now we highlight the toggles when you touch it to indicate that you are controlling the toggle. We also compensated for the touch bias. User tended to touch below the toggle. The color of on and off are differentiated. And we also allow direct touch on the opposite side of the toggle. It's important to note that this last change allows an easier switch of the toggle, but this last change makes the toggle less secure. It is very rare to change the toggle state inadvertently when a sliding gesture is required. We also observed that all users spontaneously or after the first try use sliding movement to manipulate this toggle. The evaluation showed some important differences in personal preferences. And we found it difficult to recommend a single design. We think that toggles are good candidates for user customization. Nevertheless, if one toggle had to be recommended as an always acceptable toggle for first-time users, the rocker toggle is a good choice. It is immediately identified as a toggle, the state is always read properly, and it was found easy to manipulate, and the 3D design was also found attractive. The refinement we made were to use different color for on and off to allow reading without actually reading the label, and also to allow sweeping through all the toggles. This study showed that there are important differences among the alternative designs. We provided examples for practitioners to follow and describe refinements. Potential research topics include the use of toggle under stress, the study of combinations of toggles, and multiple state switches. Thank you.
Oh my God, yes, I'm sorry. I was trying to be muted to eat something and I forgot to unmute. Let's see, we will learn by now. So I was saying that I didn't plan to monitor the help session here. So I will say, no, the chat room first, I'm sorry. So we'll have a time for question at the end if you want. And of course, you're always welcome to email me if you have specific questions. But just for those who came maybe in the middle, this is the historical HCIL video session, very informal, so you could eat lunch. And we either watch it together now, or you could watch it on your own. Even if you stop now, for example, you'll find the link in the symposium program for the slide with the embedded videos that are giving me trouble. So the next example of innovation from the lab that had a big impact really is the idea of dynamic queries for database search. At the time, in 1992, most of the database search were done through keyboard queries, where you type kind of a complex queries that people make a lot of mistakes and don't always return anything. So we thought of a new idea, a new way of doing this. And we called it dynamic queries. And the first example was an example with what we call the home finder, with a map with houses, and people would adjust sliders or click on button to reduce the number of houses on the screen that they could find in the database. So an example of what you see now might be Kayak or other tools that let you search with sliders and selecting buttons and finding on the map things you are looking for, like an hotel or something like this. But today, because I was trying to select some of the videos where that I made and that were more maybe relevant for today, I picked this example of a dynamic query, which we call Dynamaps, we were doing dynamic queries on a health statistic atlas. Since we have been looking at a lot of data online with the pandemic, I thought you might be interested. And then what you'll see is that you'll see how people were looking at health data at that time, which is mostly on paper with atlases created by the National Center for Health Statistics, who was the sponsor for this project. So I'm going to start the video, make it large, and let you watch it.
Hello, I am Catherine Plaisant, and this is Vinit Jain from the Human-Computer Interaction Laboratory of the University of Maryland. We will show you how you can use dynamic queries to explore data, in this case, health data, as we are working with the US National Center for Health Statistics. Typically, statistics are tables of averages, bar charts, graphs, and also long pages of numbers. In the field of epidemiology, which deal with the incidence, distribution, and control of diseases, maps are often used to identify geographic clusters and eventually find similar patterns between maps. For example, these show rates of cardiovascular disease mortality, and this map, which has a similar pattern, shows the percentage of the population working in manufacturing. The most famous example is this map, which showed how all the cholera cases in 1854 in London were linked to a single water well. There are now atlases like this Cancer Mortality NIH Atlas. It is an impressive collection of maps, but access to details is lost since everything is split in only a few categories, here 5. So I cannot tell what is the cancer rate in my county. To show trends on paper, graphs or series of maps are used. This work shows the spread over 6 weeks of an influenza-like illness in France. Computer programs have been also used to generate canned animations, which are very powerful to illustrate trends. Geographical information systems are now becoming more available. They are powerful, but often still slow to use, and mainly oriented towards the generation of maps, more than the casual and fast browsing among maps. We believe that giving fast access to maps and the direct control of the animation can help researchers to engage in exploratory tasks such as hypothesis formulation. How can dynamic queries help? Dynamic queries apply the principle of direct manipulation to querying. Direct manipulation implies a visual representation of the world of action, rapid, incremental, and reversible actions, and immediate and continuous feedback. Dynamic queries are user-controlled animated displays of spatial or textual data. One of our first applications was a DC home finder, which helps locate in a few seconds a subset of houses that match the query, which is interactively adjusted. Our experiments have demonstrated that dynamic queries were very powerful in finding trends and exceptions. For the National Center for Health Statistics, dynamic queries were immediately recognized as an excellent tool to explore health time trends. Let's look at the prototype. Here, we have mapped cervix cancer mortality rates for white females. Bright reds means high rates, low rates are blue. On the side, a time slider let me change the year for which data is displayed. When I slide from 1950 to 1970, I can clearly see that things are globally improving, reds being replaced by blues. In the case of cervix cancer, this is probably due to the increasing use of pap smears, which allows early detection and treatment. Opposed to the paper maps of the traditional atlas, I can access the exact values easily by clicking where I want. I can also pose some simple queries, like give me the only states with a high percentage of college-educated people and a large number of smokers. The side sliders act as filters, and the states that do not answer the query disappear from the map. As you could see, not too many states answer that query. I want to mention that this is working on a 386 PC, and that the animation uses color palette changes. It shows that it is becoming possible to do animation and explore data interactively on common machines. But the hidden benefit of such an interactive tool for the researcher might be the possibility of seeing correlations by looking at the patterns of disappearance of the states. For example, when I slide this slider which filters on the average income, I am making disappear the high income states first, and only the low income states remain at the end. I do it again. Look at the reddish states. Notice that they stay until late, suggesting a possible correlation. The same thing seems to happen for the percentage of college-educated population, probably because high income and college-educated women are more likely to be followed by a doctor and seek treatment. Our newer prototype uses smaller areas. We're facing speed issues because we wish to keep working on common 386 equipment. But zooming is possible to keep fast animation. And we are optimistic that new development will make it possible to keep real-time animation like this, which is necessary to dynamic queries. Animated maps are a powerful tool to prompt scientific insight and illustrate findings in a convincing manner. We demonstrated that it is now possible to give the direct control of the animation to the user while keeping access to detailed data and a simple querying mechanism. We are looking for other techniques to provide grand tour of large amount of data to help discover patterns and identify possible correlations. Thank you.
All right. Moving on to the next one. I wanted to say a few comments because the previous one that it's true. Like now, it seems completely ordinary to see those animation, the map animation, even on the web. But I lost the train of thought. But we wanted to, find clearly the dynamic query. Oh, that's right. I remember now. The point I wanted to make was that dynamic queries were really a filtering mechanism. You're not verifying any hypothesis really, but the main goal was to provide tools, and that's true for most of the information visualization tools we have, is a way to help people, analysts, make hypotheses. You could not verify that there was a correlation here, but you could think that maybe there is one, and then you would go and verify it in some other way. So the next demo, and I see we still have time to show it, is about query preview. here the idea is that people had seen the dynamic query, but it only worked with small databases. And then NASA, who happened to be next door to our university, came to us and said, we would love to do this for a much larger data set, which even for now, it's still not that huge. But they wanted ways for people to find the data sets of interest within their large collections of data sets. So we come up with the idea of query previews. And what's interesting is that this idea was later on an inspiration for Marty Earth to design faceted search, which is now what you find everywhere in all the e-commerce and other type of tool, where you see, in both cases, you see a selection of attributes and you could pick what you want and you could see how many items there is. And that was the idea that was introduced with query preview in 96. So let's see the video. And again, I started, make it big. Why doesn't it make it big when I ask for it to make it big? I do not understand. I'm making big.
Hi, I'm Catherine Plaisant.
And I'm Tom Bruns.
We are from the Human-Computer Interaction Lab of the University of Maryland. We will present a prototype of a user interface for NASA's EOSDIS project.
EOSDIS is the information management component of the Earth observing system. It will collect data from a variety of platforms and store the data sets in designated archive centers. Data users will browse, request, and download data sets over computer networks.
The current prototype offered by NASA is a classic form fill-in interface. Relatively complex queries are possible, but it is difficult to avoid the zero-hit problem or even estimate how much is available.
To facilitate querying and browsing, we extended our dynamic query interfaces to take into account the new challenges of EOSDIS.
Our early dynamic queries prototypes have shown that novices or expert users could rapidly query databases, explore trends, and find exceptions. But those prototypes used only a few thousand records, all in local storage, while EOSDIS implies more attributes and more records which are distributed on the network.
To keep real-time interaction under those conditions, we propose a two-step approach. In the first phase, called Query Preview, users query all data sets by specifying rough ranges over only a few attributes. Here we see three attributes: geographic location, parameter, and time. Preview bars show the number of data sets available for each attribute value. We can see that there are many data sets for North America and not as many for the Atlantic. More vegetation data sets than precipitation data sets. Note that the numbers used in this demo are not real. When a user makes a selection, for example, selecting North America, the preview bars change to reflect the number of data sets that still satisfy the query. We now see the distribution of data sets for North America. The result bar at the bottom of the screen shows the number of data sets selected. 766 data sets is too much to download, so the bar appears red.
This approach relies on the data centers maintaining their counts of data sets which are downloaded when the user initiates an EOSDIS session.
In a similar manner, we can choose parameters, for example, vegetation and land classification, and choose some years where data is available. There are no more zero-hit queries since we can see what data is available. With a few selections, we have quickly filtered out the bulk of the data sets. The total number selected is 66. We are now ready to proceed to the second phase of the query. The metadata of the 66 datasets is downloaded from the data archives.
In the query refinement panel, we see the 66 datasets and their coverage over the years we had selected, from 86 to 88. The y-axis spreads datasets by size. Dynamic queries prototypes have shown that novice
Dr. Plaisant, you're muted.
I'm unmuted again. Oh, here we go. So I stopped the video here because I think we want you to have some time to take a little break before you start the next session again. And go back to the slides here. I'm just going to add one more comment, which is, oh, that's really crazy. Didn't go to the right one. One more comment about this idea, about the fact that NASA, when we showed them this prototype, and that's the slightly later version of the prototype, they thought we had it wrong because it was showing data from the 1700 or the 1800, and they thought, like, where did you get this data? There was something wrong. Well, they had not realized that there was actually I-score data in the data set. Now, the people who worked with us had not realized, and that's why they were such old data set, because they were representing data from those past years. So again, the idea was to really show a preview of what's in the system, what's available, and let you narrow very quickly to what you want, which is what now people can do with when you're shopping for shoes or for anything else on the web. So I'm gonna stop here. There is more videos that you could look at online on your own if you want, like Lifeline, which was a way to summarize a personal record. It was a medical record, but we used it originally for showing juvenile justice records. And there is another one I picked was the tree map, which is also an invention from the lab, Ben Shneiderman, and is now found in many places also, like here in this case, a tree map that summarizes, I think it's about 200 stocks, and telling you the green ones are going up and the red ones are going down. So summarized in one screen. And there is plenty more videos that you could look at, obviously, either in the Chi videos from HCIL or the HCIL videos in general, and then of course all the historical Chi videos. So again, to repeat what the video at the beginning said, I encourage all of you who are doing any work on development to record your demonstration, because they will not run forever. Even, maybe next year they won't even run, but in 40 years, I could guarantee you that they will not run. And also, making them available ideally in an archival place so that they could be found in the future. So thank you very much. I really hope you enjoy those stories from the past. When we are done, I will look at the chat and try to answer some of the questions right away. And again, do not hesitate to contact me if you have any questions. And what we'll do also is we'll put, I hope the student volunteer could help by posting the links for the first session in the chat so that everybody could find them easily. All right, thank you very much, everybody. I hope you were able to eat more than I did. And okay, enjoy the afternoon. Bye-bye.